All right, in this lesson we're going to talk about equilateral and isosceles triangles. So a triangle is isosceles when it has at least two congruent sides. When an isosceles triangle has exactly two congruent sides, these two congruent sides are called the legs. The angle formed by the legs is the vertex angle, and the third side, the non-congruent side, is the base of the isosceles triangle. And then the remaining two angles that are formed by the base are called, oddly enough, the base angles. So what does that look like? It looks like, so this is a leg, this is a leg, they're the congruent sides. The angle formed by the legs is the vertex angle. This side down here is the base. And these two are the base angles. So that is your standard isosceles triangle. That's what we call it. And we need to know the name so that we can correctly identify what it is we're talking about. So let's look at what we're talking about and how that information helps us. Well, the base angle theorem says that if two sides of a triangle are congruent, then the angles opposite them are congruent. So if AB is congruent to AC, then angle B is congruent to angle C. So what did we do? So we just went across the triangle to find the angles. They have to be congruent. That's what the base angles theorem tells us. And oddly enough, the converse is also going to be true. So if two angles of a triangle are congruent, then the sides opposite are congruent. So if angle B is congruent to angle C, then AB is going to be congruent to AC. So we crisscross in the other direction. So if the sides of a triangle are congruent, the opposite angles are congruent. If angles in a triangle are congruent, the opposite sides are congruent. Funny thing about triangles. So let's look and recall. So if side DE is congruent to side DF, let's name the two congruent angles. Well, we are going to go across the triangle. So angle E is congruent to angle F. And if we have two congruent angles, we are going to go the other way across the triangle. And CA is going to be congruent to CB. So it's a very simple formula, very simple premise, but we have to pay attention to what we're doing. All right. So a corollary to the base angle theorems, and we remember that a corollary is just a specific rule that matches the existing theorem. and we get to carve it out because it's always going to be true. If a triangle is equilateral, then it is equiangular. So if these three sides are the same, well, I know if I have two sides the same, I can crisscross, and these angles are the same. Well, if AC and BC are congruent, A and B have to be congruent. Well, if BC and AB are congruent, then angle A and angle C have to be congruent. And we can keep going around the triangle seeing that. But if it's equilateral, then it's equiangular. And that's why most students are unfamiliar with the term equiangular in regards to triangles, because it gets shorthanded to equilateral, because every equilateral triangle is equiangular. And every equiangular triangle is equilateral. All the equilateral triangles that have ever been built and that will ever be built are equiangular. And as we know, 180 divided by 3 equals 60 degrees. So every angle here is 60 degrees now and forever. So, spoiler alert, I should have said that first. Let's find the measures of angle P, angle Q, and angle R. Well, all three sides are congruent, so all three angles are congruent. So we have 180 divided by 3. The measure of each one of these angles is going to be 60 degrees. No way around it. But we like it because it makes it easy for us. So the next one, let's find the value of x. Well, we have 3 congruent sides, so we have 3 congruent angles. So the measure of each angle is 60 degrees. So 2x equals 60. X equals 30. We want to find the value of x. And there she is. It is that simple. Let's just keep it what it is. All right, so on this next one, we got to think a little bit and work our way through what's going on. So if HG and HK are congruent, then what angles do we know? Well, we know that angle HGK right here and angle HKG right here have to be congruent, because that's our base angles theorem. But we're not done. So let's look and see what we got. So if angle KHJ, that's this one right here, is congruent to KJH, which is down here. And, oh, we haven't used pink yet. It's down here. Well, they're congruent. Then the converse to the base angles theorem tells us to crisscross. And then segment HK is congruent to segment JK. That's the converse of the base angles theorem. All right, now we got to find the length of segment ST for the triangle. Well, here we have 3 congruent sides, and we know the corollary to the converse of the base angles theorem says that if a triangle is equiangular, then it is equilateral. So equilateral means all 3 sides are congruent. So ST is going to equal 5. All right, let's get to a little more difficult ones. So find the values of x and y in the diagram. Well, so which one do we want to find first? Well, we can see in this section of triangle, right here, we have 3 congruent angles. So we have 3 congruent sides. So we know that y has to equal 4 because this side is 4 and this side is 4. So that's y. So let's look at x. Well, in this triangle down here, we have 2 congruent angles. We know ln is 4 from the previous triangle. Lm also has to equal 4. So x plus 1 has to equal 4. So our x equals 3. Mix and match. Use the individual triangles together or apart as it works best for the work you're doing. Because we also have this big triangle here that we don't need to use in this instance, but we could if it benefited us. So let's go through the process again. Find the values of x and y. All right, so x, we've got this circle up here, which means degrees, means it's that angle. Well, we don't know anything about that angle yet. So let's skip it and move to y. Well, once again, I see 3 congruent angles in this triangle. So I want to use this to my advantage because it seems like the easiest thing to do. So we know all these sides have to be 28. For y has to equal 28. So y equals 7. Well, here, these two sides are 28. So these two angles are going to be congruent. Let's make that just a touch darker. And so here on this triangle, we know this is 2x. That does not help us solve for x. But what we can do is using any rules that are available to us, which are all of them, right here is a straight line. Straight line is a straight angle, so it's 180 degrees. We know that this equilateral triangle is also equiangular. So this angle right here is 60 degrees. 180 minus 60 is 120. So that means this is 120 degrees, which leaves us with 60 left over for the 2 remaining angles, which are congruent. So 2x is going to equal 30, or we could say that 4x equals 60. Both get us to the same spot where x equals 15. Whatever you're most comfortable with. We could also say that 2x and 2x are going to equal 60 because it's an exterior angle of our triangle. Any rules that apply will always apply. All right, actually these next three, why don't you go ahead and pause the video, work through them, then start the video and we'll see how you did. All right, so x degrees, so we're talking about this angle. I've got 3 congruent sides, so x is going to be 60 because all these angles are 60 degrees. Well, right here I have a right angle, and that right angle is 90 degrees. So that's 60, and here's got to be 30. I have congruent sides, so that means these two little angles have to also be the same, so they're both 30. So that's 60, so y equals 120. Very simple. Follow the rules. Use whatever rules help you. All right, now the middle one. We've got 3y equals 1. We've got an equiangular triangle, which means it is equilateral. So 3y minus 1 equals 17, because this is 17 and this is 17. Because equiangular means equilateral. Okay, easy enough. And then here we have an isosceles triangle. So when we crisscross, this means this has to be 17. So 2x plus 1 equals 17. So in our middle problem, y is going to equal 6, x is going to equal 8. Now, in the third one, I would be very surprised if you were able to get this one because we're missing a piece of information. It appears we have a bad diagram. But if we put that in, that makes this 10, and this 10. So y equals 10. Well, equilateral triangle, 60 degrees. So we get 30 here. We got 120 there. So x equals 30. And we are done.